Question 4. Hydroxyethanol has been observed in dust clouds near the center of our galaxy. Predict the bond angles between X and Y in the predict the bond angles labeled X and Y in the diagram of hydroxyethanol. Now let's check here. In carbon, carbon here has 4 bond angles. So using valence shell electron pair repulsion theory, these ones here, all the 4 bonds, that is tetrahedral. So if it is tetrahedral, all of these bonds are going to be equal to, the angle is going to be equal to 109.5, or sometimes they put 109 to 110. So if you put a figure within that range, that is it. So X has to be that 109.5. Okay, I don't need to put degrees because it is already there. And then for Y, these are 3 bond angles. So angles at a point add up to 360. So these ones are 3. So that will be 100 and what? And 20. So 120. As simple as that. Then hydroxyethanol reacts separately with 2,4-dinitrophenylhydrazine and with TOLLEN'S reagent. State what you would observe in each reaction. Of course, with 2,4-dinitrophenylhydrazine, there is an orange precipitate. Okay, this one tests for the presence of a carbonyl, and already we see a carbonyl here, the aldehyde. So we shall have that orange precipitate. Orange precipitate. Then TOLLEN'S reagent is ammoniacal silver nitrate. That one can give a positive test with aldehydes but not ketones. Okay, and the positive test, we see a silver mirror. Okay, a silver mirror, but ketones don't do. And of course, we are seeing what? An aldehyde. All right. Then next, part C, hydroxyethanol is converted to ethanoic acid when it reacts with excess acidified dichromate. State the role of acidified dichromate 6 ions. Of course, this is an oxidizing agent. They even said, why is it an oxidizing agent? This one oxidizes, it's a strong oxidizing agent, so it oxidizes a primary alcohol, because this is CH2OH, this is a primary alcohol to a carboxylic acid, and then this one here, the aldehyde, to a carboxylic acid. This one is first taken to an aldehyde, then oxidized further to a carboxylic acid. So this one is an oxidizing agent. That's all I'll write. Oxidizing, or it can be S, oxidizing agent. And then Roman 2, state and explain any other necessary conditions for this reaction to be successful. So we must have excess dichromate. Okay, excess dichromate. And you have to heat it under reflux, right? Heat under reflux. Because if you heat and you distill, that means you can get maybe carboxylic acid here, but then here you get an aldehyde. But if you heat under reflux, what is oxidized here is oxidized further, nothing escapes. Okay, so that's why we heat under reflux to allow oxidation of alcohol and the aldehyde groups. As simple as that. Then part D, hydroxyethanol can be reduced to ethane 1,2-diol. Okay. This is the one here. So you just reduce here, then it comes to a primary alcohol. Write an equation for the reduction of this hydroxyethanol to that ethane 1,2-diol. Use this H to represent an atom of hydrogen from the reducing agent. Okay, so we are going to have CH2 Okay, here, then there is OH, and then CHO. Okay, then I can add the hydrogens. Then we get CH2OH. Say we put a 2 here. So let's try to see the hydrogens that have been added. Right from here, when you check this, there are 2 hydrogens that are added. If I can just say there is O and H. There was O and H, but then 2 hydrogens are added. So that means I will just come to this one and I put a 2. 2 hydrogens were added, as simple as that. Identify a reagent for this reduction. It can be either lithium aluminium tetrahydride or sodium hydroborate. Even this one can work. Because for sodium hydroborate, it can reduce the carbonyl compounds to alcohols, but it cannot reduce the carboxylic acids. So the one that can reduce carboxylic acids to alcohols is this lithium aluminium tetrahydride. Keep that in mind. Roman 3, this ethane 1,2-diol also forms when an alkene A reacts with cold, dilute acidified potassium permanganate ions. Yes. So name A. Of course, that one has to be, if this one is CH, and then we are seeing an OH here, then C, then H, then an OH. Then remove these ones here, put a double bond here. That will be what? Ethene. It reacts with an alkene. This cold dilute acidified potassium permanganate reacts with alkenes to form a diol. So you just remove the double bond and then you put the OHs on the 2 carbons that are in that double bond. Okay? All right. So thank you so much. This has been it for this paper. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.